Hi, my name is Alex Castaneda, and this is me presenting the shortcomings for the geometric visualization tool that was done during Capstone Spring 2024. And the team members are me, Alex Castaneda, Anthony Thompson, Jin Pan Zhang, Alex Navarez, and Joseph Mejia. Our project owner was Mr. Professor Antonio Hernandez, and our capstone professor was Masad Sajidi. So in this presentation slide, we have the shortcomings that were unsolved in our development phase. We were starting off completely from scratch in this project, so all the basics had to be done. So when complexity scales up, for example, a geometric object such as polygons with holes, we didn't have much time because when it was even possible to do this geometric object, was after we did all the basics such as point, line, ray, line segment, circle, triangle, rectangle, and of course polygons. And again, when this all these basic objects were completed and Voronoi was completed and triangulation was completed, is when we were finally able to even start doing polygons with holes, because the hole in a polygon with hole can be the shape of any of these previously mentioned objects. Right here is the seagull reference for polygons with holes. And then our capstone team was unable to implement in time as well the data structure doubly connected edge list, which is abbreviated as DCEL, in which it's used for graphing planar straight line graphs. And the reason we were unable to do this is because, again, just as the previous one, we needed to implement things, all these shapes beforehand. We needed to implement Voronoi and triangulation beforehand to do this decel. And then also, when it was even possible for us to do that, we had to go back to the building blocks and redo them, such as mentioned here at the bottom, in which the edges for decel geometric object have to be broken down into subdivisions, and we really didn't have time to, go back to the basics and redo them for decel. So our wish list is, of course, for the future teams to finish with our shortcomings, but also we want this project to be building up in complexity, and we believe the best way is again by having more extensive building blocks. And when we were researching the other building blocks that could diversify what can be done is things such as weighted points on top of points, curves, the bounding box in the 2D aspect, and below is a seagull reference for all of these, of course, in 2D. And then as well, we want to integrate some of the more complex things that the Seagull library has, and some of that is geometric transformations. And there's three types of basic transformations that can be done: the affine, the rigid, and the deformable. That's implemented in Seagull, can be implemented and extracted in C++ and in Java for the future capstone students, and as well as to fill out the capableness of this tool and framework, we want a total of 4 algorithms or geometric data structures, and there is currently only 2. So one of the ways that it could be extended is that different versions of each algorithms, there are different Voronoi that could be done, but also mainly different triangulations. We have the basic Delaney triangulation and can be added. The next one is constrained triangulation, which, as you see in the image below, is able to, scale in complexity again. And the other two basic general types of algorithms that we wanted to be added is a convex hole, which does divide and conquer as seen in the image below. And we also want the vertical ray shooting arrangement added, It's the next general algorithms to be added to have in total 4. And yeah, we feel these are the best ones to again scale in complexity. And this is the main focus that would be outlined for future capstone groups, which again complete our shortcomings of decel and polygon holes, scale up the basic complexity or possible diversification with the building blocks such as weighted points, curves, bounding box, the transformations, and again, the end goal of having at least 4 general types of algorithms, adding convex hull and vertical ray for 4, and then specific instances of each such as constrained Delaney. And these are our references.